This is the K-12 Engineering Education Podcast for December 5th, 2016. The other day, I visited the classroom of Audrea, a high school engineering teacher here in Austin who has many years of experience teaching computer-aided drafting, or CAD, along with manual drafting. You might know that drafting is the skill of representing physical designs in technical drawings, and it's closely related to engineering. I spoke to Audrea in her classroom about what she's learned teaching CAD and engineering to kids.
My name is Audrea Moyers, and I teach engineering. I teach a pathway of engineering courses at McCallum High School, and that includes a couple courses that focus pretty heavily on engineering drawing. So that would include both 2D and 3D CAD.
Okay. All on the computer, or you do?
So we do in the third level class, which is this. It's called Advanced Engineering Design Presentation. We do about 4 weeks of manual drafting, which I do because my classes articulate to Austin Community College, and they have an advisory board, and their advisory board has professionals that say you still sometimes need to be able to manually draft. Maybe drawings have been submitted to the city and you can't take the drawings out, you need to make a change, you need to actually make a change on the scale drawing. So they say it's still a skill, so they do it in their courses. So I do it, and I don't do it at the beginning of my first CAD class, because the one year I did that, the kids dropped like flies, because I'm making them do, very old school T-square triangle drafting, and that was only a piece of the class, just a small piece. But when I did it at the beginning, kids were not happy with that, and so I now tuck it into the curriculum a little bit later. They've already kind of committed. They've done a whole year really of CAD before I say, hey, let's learn how to do some of this stuff by hand. It's hard because there are just some really basic neatness issues with it, not just like the geometry. The conceptual hardness is not really any harder than CAD, but just line quality, learning how to draw a neat straight line and sharp dark corners and using the compass. I mean, a lot of the kids are just struggling with the tools, and a lot of it's just drawing enough that the tools are not an impediment to getting the drawing down. And so that's the real hurdle with the manual drafting is the tool use,
So they have to learn a little bit of patience or something.
They do, and some kids love it, and other kids can't stand it. They're like, when are we going back to CAD? But I think it's good. I see a definite progression in all of them. Their drawings are neater, and all that. Their line quality is better by the time they're done. And some of it's just practice.
And how long again? How many years have you been teaching CAD?
I've been teaching CAD for 16 years. So of all the courses I've taught, that's the most consistent. So most of my courses have kind of evolved over time from kind of just an introductory sort of technology credit to full-on engineering design. But I've had a CAD class more or less unchanged for about 16 years.
Wow. So you know what you're doing.
Yeah, and the software, keeps updating, but the concepts have not changed. I mean, AutoCAD as a program is pretty much like it was 30 years ago when I used it. It's just got a lot more bells and whistles to make drawing easier, but the concepts of it are pretty much the same. I guess the big change is 3D modeling. The programs like SolidWorks and Inventor didn't even really exist when I started teaching CAD.
So what software do you use in your classes, and why?
I've been teaching AutoCAD the whole time, and so partly that's because I think it's kind of the industry standard. So if you're going to learn one CAD program, I think that AutoCAD's a really good one to learn, and then you can quickly learn other programs from that. Also because of our articulation agreements. And so my courses do articulate to courses at Austin Community College, and they use AutoCAD. And so as long as kids can get some college credit here at the high school level, then I'll be using the same software. So that's the 2D program. For 3D, I've used a couple different programs over the years. I started with SolidWorks. We got a grant for that for a few years, but eventually, that grant money was done. We were several versions behind. And so Autodesk had a package where you could get what they call like the design suite. And so I was using Inventor at that point for 3D modeling. Mm-hmm. And now, of course, Autodesk has made everything free for education. And so it's definitely a reason to use it, because then my students can get it at home if they want to. Not many need to. Mm-hmm. A few choose to do it. But they have that option that they can continue using this program in college. So I think it's a versatile one that they can take with them after they leave.
So then if a lot of companies like Autodesk, they have the software for free, other companies might have it at low cost for education, is there any reason to use a package like SketchUp or something that's a little less powerful?
I actually do use SketchUp also,
okay.
And I do use SketchUp for the architectural work. So I do both. Right. Okay. I do both engineering and architectural design and drafting. And SketchUp is designed for architecture, so it works very well as a just jump in and start using it. So it's super easy to use, but it's not as powerful. And so it's a great kind of early design tool. And I use it in both my introductory class, which is mostly freshmen. We do a really small architectural project, like a specialized room. And they can, after they've done their 2D design, like a floor plan, then they can do the 3D, the height and the roof and everything else, in SketchUp pretty easily. And the pro version even lets you take your floor plan and just bring it right in and make it 3D. Oh, cool. With the older version, the free version, I think they call it Make now, we had to kind of redraw the room outline to make it 3D. Mm-hmm. And that pro version does cost, but again, there's a grant, from a teacher group, right? This allows you to get it for low cost or no cost.
So we know that you teach both CAD and engineering and manual drafting. From your perspective as a teacher, what's the difference between these courses?
Well, I'll say first that CAD, to me, teaching CAD has two components. One is the software, so the tools of just the program, but the other big component is the theory of technical drawing. And so you can't really separate teaching CAD from teaching how do we draw designs. And so the CAD course does tend to focus first on just learning the software, but really the majority of it is the theory of how do we take a three-dimensional design and draw it in 2 dimensions. And we do get increasingly sophisticated with the software, but a lot of the real thinking and the real challenge is in the theory part of it. Mm-hmm. And so to me, the way my pathway works is my introductory class has a CAD unit in it because it's just a really useful tool. So we learn it early so that throughout the year, if we want to draw something precisely, we have a tool now to draw precisely. But the most of the work we do in that class is more kind of conceptual kind of design stuff. And then the next 2 classes do focus heavily on how do you draw designs and how do you learn the rules of drafting, kind of as an international language to share a mechanical design or a circuit diagram or an architectural drawing with someone, in another country or another city, right, when you're not physically present. And then my final class is you teach engineering world curriculum, which doesn't have really any kind of CAD component to it. But when students have taken the other classes in it, then they have, I think, an advantage that they have a tool to help them draw their design accurately. And so I feel like at the most basic level, teaching CAD gives them a tool to draw accurately. Mm-hmm. So they might have experience with other drawing programs or other types of drawing from art. They might have learned how to draw perspective drawings. They might know Photoshop or Illustrator. But they usually haven't had a program, when I get them, that gives them precision, that gives them tools to be precise about drawing. And so if they were going to try to represent a design, if they went to one of those other programs, they would find it very hard to be precise, right? They have tools to make cool filters and things like that, but not tools to be, exact.
Right.
And so it's a lot of what it does is it gives you just this set of geometry tools that are exact. And then once they know how to use it as just software, then they can start incorporating it into design projects. Mm-hmm. So they can either... Now AutoCAD is not particularly useful in the early stages of design. It is really meant to be final documentation, right? The first thing AutoCAD wants when you draw a line is how long's the line. And if you're still thinking about what shape something should be, right, that's not what you need. So it's not AutoCAD itself is not a design tool, but other programs like SolidWorks and Inventor and SketchUp they do have a way that you can be a little bit looser, right? And you can make some decisions that you can then change your mind on later and kind of shape it. Exactly. So parametric modeling, and AutoCAD's moving that direction, but it's not that direction yet. So so a lot of it does depend on which CAD program you're using, but and that's really, I think, where AutoCAD can benefit the engineering curriculum, is that it's a tool to represent your final design. And so in that final course where they're doing, like right now, they're doing a pinhole camera design, the students who have had a CAD class can very quickly and very accurately convey their design using a variety of techniques. They could make an isometric drawing of it. They could make a 3D model of it. They could make an orthographic projection with top, front, and right views. And they would be able to do it using industry standard techniques like hidden lines and center lines and things like that. So they just have basically an advantage on sharing the idea with others.
Sure. So for their final report.
Right, for their final report, they're able to, convey really very precisely what their design is. And students who haven't had CAD can still make those drawings, but they're usually not as detailed, right, and much more time consuming because they haven't had the chance to really learn those drawing tools. I also try to put some design into the CAD classes. It's not as easy. There's a lot of just curriculum that's just learning the drawing, but it is best if they can draw their own designs and not draw someone else's designs. And so I'm most able to do that with the architectural unit and when we do 3D modeling. So they have a project where they're not modeling just some shape I give them, but they have a client and they're trying to design some sort of little product for a client, and they're modeling their own design. Yeah. And there's a big difference in modeling your own design that you're still thinking about in your head and just recreating shapes that somebody gives you. Yeah. And so there's a huge leap there. So I try as much as I can, time-wise, to put some design into the CAD courses as well.
That was going to be my next question, how you might incorporate design into your CAD classes, because I would think that your CAD classes are really full as well. Mm-hmm. How can you do that and still have your kids take something away from
It's mostly in the spring semester. I mean, in the fall semester, we're trying to get the basics done. Mm-hmm. And that's when we get a lot of our curriculum that articulates to the community college. We kind of really get very, very good at CAD. We do mostly other people's drawings, right? We're drawing, various mechanical parts that have to fit together, and we're learning section views and all the rules of drawing. Mm-hmm. And then in the spring, I have a little bit more time, and we do a 3D modeling project that really doesn't articulate to ACC. This is really an addition, where they do have their own project to do. So after they've learned the basics of Inventor, well, then they get to model something that's original. And that's where the 3D printer comes in, where they can actually print it, and then that abstract shape on the screen, is it the right size? Does it fit the part it's supposed to fit? That's where the rubber meets the road on the design.
Are they interested in that? Like the kids who take CAD classes, are they really into the design?
They are. I think that they get tired of just drawing other people's things, which I have to say, we got to learn the rules with this, but then we want to apply them to something else. And my third class, which is the advanced CAD, I don't do all the ACC curriculum, because if I did, we'd spend the whole year drawing other people's designs, and I think the kids need to be able to apply it, their own ideas, and then figure out, how do I draw this idea I have in my head? How do I actually represent that in 2 dimensions? And so I can do that a little bit more with the architectural projects too.
Yeah. So that's interesting you put it that way. So it sounds like your engineering class helps you get the idea in the first place, and your CAD classes help you bring that idea into paper or reality.
Yes, and I think there's, so we don't have as much time in the CAD class to talk about like ideation, how do you come up with good ideas? How do you choose a good idea? So we can talk about those, but we don't spend as much time learning those techniques. We spend more time learning the representation techniques. And then, that more complete design course for engineering gives a lot more about the design process. I mean, I start talking about the design process in their freshman year, probably the end of the first week. So I talk about it a lot, but it's harder to demonstrate it, right, until you get to those big design projects. So.
You had mentioned that sometimes there's challenges retaining your kids in the CAD classes. Do you have the same challenge in your engineering classes? And if so, what are other ways you can overcome that?
You mean retaining like year to year? Is that what you mean? I'm not sure.
Or getting, like, the people who went into your CAD class at first, if you started with manual
Right,
drawing, they
okay.
just dropped out. I guess my bigger question is, what types of kids go to these classes, and how do you keep them there?
Okay. Well, it's interesting that I've seen a big shift. You know, the state of Texas has moved to endorsements for graduation. And so there's now a STEM or engineering endorsement. And so what I find is I've been able to keep kids through the entire 4-year pathway a lot better in the last few years. But before, I could get them to take maybe the first 2, and then around their junior year, they have a lot of other things they want to take. Maybe they wouldn't take the 3rd class, you know, and so I'd get some that would do a year or 2, but maybe not the full pathway. I think there's a little bit more incentive now to maybe try to complete a whole pathway. So I've got, for the first time ever, my 3rd year class of juniors is totally full at 30.
Oh, wow.
And so I usually have a lot of drop off between the 2nd and 3rd year. You know, they get to CAD, then they're not necessarily going to do the 3rd year. They're going to, you know, they trickle off. The students that take the classes, I think, are students that kind of come in interested in design of some kind. There's a word of mouth component, but a lot of it is like they've either heard about engineering or architecture, and they want to explore design. And I find that once I get them in the first class, if CAD doesn't scare them away, I can keep them, you know. But some of them do. They get to that first CAD unit, and they think that kind of very precise way of thinking maybe isn't what they're interested in. So sometimes I have to work with them in the rest of the class to make sure they don't get scared off just by AutoCAD. Because one thing I guess that hasn't come up is that's really significant, I think, about teaching CAD is part of success in that is visualization. And so there's when you're drawing a 3-dimensional object in 2 dimensions, you have to be able to visualize and abstract that. You know, they don't actually represent the real object. Things like hidden lines and center lines don't really exist. They're meant to convey some information. And so there are students that get the software easily but struggle with visualization. And that is a skill that's really important. You know, research has shown that visualization skills and, you know, relate to success in engineering in college.
Yeah, so much of a big predictor that they actually have programs now in college trying to
get that.
help people get that skill.
Yeah.
Do you notice that your kids get better at
I
visualizing
do.
things?
I notice that there's some definite innate abilities right away, that some kids need more assistance, and so there's some techniques, you know, to help them try to visualize. And we do a lot of sketching type visualization too. A lot of it's not just in CAD, but like looking at an object and identifying surfaces, sketching an object in 3 views, sketching an object as an isometric, and they do become more skilled at that. And then the flip side, looking at a 2D drawing and figuring out what 3D, what that would look, what implications does that have in 3D?
Yeah.
That in some ways is kind of harder. And then when they do their own designs, the object doesn't even exist yet. It's just an idea.
Yeah.
Then they have to figure out how to draw that idea.
And do they do CAD on electrical circuits too? Because I know you mentioned it, but
We're doing that right now in my advanced CAD, so they're making a circuit diagram,
Cool.
which is a totally different way of using CAD
Yeah.
because it doesn't have dimension. It's much more diagrammatic. But it has some advanced tools like what we call attributed blocks and XREFs that teach them some advanced CAD to make that drawing easier and more accurate. But it's like a whole other way to do CAD. So it just lets them see, it doesn't have to be floor plan dimensions or exact geometries of a part that's going to be manufactured.
And if you had any last advice for schools who may not have an engineering or a CAD program, how can you get one started?
I actually think it's pretty easy to get one started because the software's available pretty much for free now. There's a lot of online tutorials and free resources that if you just have a little bit of initiative, you know, you can learn it. But I'd also tell a teacher to look at their community college. You know, I would tell someone here in Austin to go take drafting 1405 at ACC, you know, and or audit it and learn it there, and then start, you know, kind of teaching what you learn in that. But there's so many resources now for that and even programs like SketchUp, you know, that you could jump in on an architectural end. And the kids are totally willing to jump in with you on that. I feel you don't have to like know everything to start getting the kids involved in that and learning that software.
I'm sure there's resources on YouTube and everything else.
Absolutely. There's so much. I have a lot of kids that are teaching them, or a few kids that are teaching themselves Revit right now, which is pretty advanced 3D modeling for architecture. And they're just going through a series of videos that are probably put out by Autodesk and just kind of teaching themselves how to use the program, So there's some pretty neat tools out there. My advice would be just jump in and start doing it. And your kids will totally be with you, especially if it's 3D modeling.
Cool. Thank you, Audrea.
You're welcome.
Appreciate it.
Thanks to Audrea for letting me pick her brain on all these tools. If you got something out of this podcast, please subscribe and leave me reviews on iTunes, SoundCloud, or Stitcher. And send me comments on Twitter, Reddit, or Facebook. All of that will help others find the podcast too. You can find links at k12engineering.net. Our opening music comes from School Zone by the Honorable Sleaze. Our closing music is from Late for School by Bleep Tour. Both are used under Creative Commons Attribution licenses. The K-12 Engineering Education Podcast is a production of Pios Labs. So everybody, until next time, take care. Hey there, it's Pius again. I'm excited to remind everyone that we're testing out some new ideas for integrating the arts and engineering at South by Southwest in March 2017 in Austin. Check out our sessions. One is on integrating electronics, textiles, and programming, and another is on using improv and art games to boost your product design skills. Hope to see you there in March.